Unit number 1. I would like to share my screen. Is it clear? My audio, everything is clear. Any problem, you please raise. There is no issue, no problem. If any issue, please let me know. Is my screen visible to you?
Yes, sir.
Okay.
Today will
Yeah, if you are ready with the instruments, let us start drawing on the drawing sheets, or at least by the next week. Okay, come with all the instruments with the drawing sheet. Okay, so I will tell you step by step procedure. So along with me, you can practice. Okay. Yeah, today we will see how to draw some conic sections like parabola, ellipse, and hyperbola. Okay. Before that, you look at the figures I am showing you on the screen. So these are, right circular cone is there, right? So this is in the form of right circular cone. If you cut the cone at different angles, okay, you will get different conic sections. So you are looking at three different cutting planes, right? So here first figure, you see the cutting plane is at an angle, and in the second figure, the cutting plane is at a different angle. And if you see the third figure, the cutting plane is somehow it is vertical in position, right? So accordingly, you can also see the curves generated. If you can able to identify, you can easily understand. Here you see, if the angle is something like this, you will get some parabola here. If you cut at this particular angle, you are getting, you see the elliptical shape here. Some drawn line is there, right? And if you cut like this, you are getting two branches of hyperbola, one here and another here. So that means if you take a right circular cone and cut the cone at different angles, we will generate different curves. Okay. In mathematical sense, if you see, forget about the lower right circular cone. If you consider only the upper right circular cone, if you cut the angle with reference to the axis, for example, with vertical, okay, if the cutting plane or the red axis line is there, right, that is the cutting plane angle theta. Okay, if it is greater than 90 degrees and less than, okay, see the relation between theta and alpha. Okay, theta is more, okay, compared to the alpha, then you will generate elliptical curve. Similarly, the parabola, see the angle here, parabola. Okay, you can identify the differences. Here you see that theta is equal to alpha. That means with respect to axis, vertical axis, okay, if this alpha is equal to theta, okay, this cutting plane angle. Alpha you can easily understand from the diagram. This is the semi cone angle. This is the full cone angle, right? Half of the cone angle is alpha, okay. And if the cutting plane, if you cut the cone, the red dotted dash dotted line is there, right? That is the cutting. So if you take a right circular cone, cut the cone such a way that if theta is equal to, that means that cutting plane angle with respect to the axis theta is equal to alpha, then you would get parabola. Okay. Similarly here, the theta is greater than alpha. Okay. Then you will get, and moreover, one more important thing is the theta also greater than 90 degrees. Okay. So in this way, you will get different conic sections. And hyperbola is a special one. Uh, Here you see what is the angle of theta here. Anyway, cone angle Semicone angle is always alpha. What is the angle theta? Cutting plane angle with respect to the axis. What is the cutting plane angle now? Are you listening?
Yes, sir.
Yeah.
Yes, sir.
Can you guess what is theta?
90.
With respect to
Zero. Zero.
axis.
Zero.
Axis is vertical,
Zero.
and this cutting plane line is also vertical. So these two are parallel lines. So the angle is zero.
0.
Okay. Anyway, the angle theta alpha is fixed for a particular cone, right? So accordingly, you can generate hyperbolic curves. Okay. So anyway, initially I have shown you some 3D uh, pictures, right? You can easily understand. Okay. That means if you take a right circular cone, we are generating different conical sections or planes, or simply we can call it as special curves. Okay, engineering curves. So one is elliptical curve, other one is parabolic curve, and third one is hyperbolic curve. Okay, these are known as conic sections because we generate all these things from right circular cone basically. So that's why these are known as conic sections. Okay, now let us move on to how to draw these curves, okay, on the drawing sheet. Now I am sharing one more screen. So let us start with an ellipse. Okay, so is my screen visible to you?
Yes, sir.
Yes.
Yes, sir.
Now can any one of you can read what is the problem on the screen?
Construct an ellipse when the distance of the focus from the directrix is equal to 50 mm and eccentricity is 2 by 3.
Okay, I will explain what is axis, directrix, okay, centricity, all the important keywords in the problem while I am drawing on the drawing sheet. Okay, while I am explaining. So listen carefully. So here we need to construct an ellipse with the given data. Okay, first of all, note down the given data in the problem. He has mentioned that the distance of focus from the directrix is equal to 50 mm. Okay,
Sir,
and
do you want to be using notes or drawing sheets?
yeah, don't write anything. First, listen to me carefully. Okay,
Yes,
uh,
sir.
it's a simple problem. Okay, you need not write anything. You just remember the steps, step by step process. That is important. Okay.
Okay.
Uh, so he has given eccentricity 2 by 3. Okay, in the problem, and the distance of focus from the directrix is 50 mm. Okay, so this much data only given in the problem. Okay, first understand how to start the problem is you need to draw one axis line. The length of the axis is it is a large line. It is having infinite length. So according to the space available on the drawing sheet, you can take this axis line. Okay, and there is a one more perpendicular line to that axis that we call it as directrix. Directrix. Again, infinite length, but conveniently you draw some line, okay, on the drawing sheet. So axis and directrix, these are two important lines for construction of ellipse. Okay. The next important step is he has given the focus distance 50 mm from the directrix. With your ordinary mini drafter or scale, you can locate 50 mm, 5 centimeter on the axis. Note down that point as focus. Capital F means focus, small f means focus. Okay. Yeah, am I audible?
Yes, sir,
Yes,
you're
sir.
audible.
Yeah, actually power cut here. So I lost my connection. Okay. Again, I am sharing my screen. Yeah, can you see that screen?
Yes, sir.
Yes, sir.
Yes, sir.
Yeah, yeah. Okay. Now you need to locate the focus F. Remember, it is important to memorize the steps. It is very important to remember the steps. Now the focus is given 50, 50. Okay, from the directrix. Just locate F, capital F, on the axis at a distance of 50 mm. You can do with ordinary scale. Okay. Now,
Sir, should we start drawing?
uh, otherwise, please wait for some time because all are not having instruments. I am going little bit faster. Okay. Listen first carefully. Okay.
Okay, sir.
Maybe in the next time you can draw along with me. Okay.
Okay, sir. Yeah.
Because I think many of you may not have the instruments right now. Okay. I will take that information later. Please let me finish this one. Okay. And after this location of focus, divide this particular focus length into n number of equal parts. For example, eccentricity of an ellipse, all of you know that it is less than 1. Okay. Has given 2 by 3. That means 0.667. And here a very important thing is you need to add up this numerator and denominator to get the 10 number of equal parts. So 2 plus 3, I am taking 2 plus 3 equal to 5, right? So I can divide CF distance into 5 equal parts only. Okay. I will discuss
Why
why.
5 equal parts, sir?
Yeah, that's very important question. Okay, you may understood at the end of this lecture. Here, in a brief, I will tell you 2 by 3 is the ratio in which the curve is passing, the curve is going on. Okay, so you will understand. That's why first I will divide this 5 parts so that okay, uh, you need to locate. There is an important term in our particular uh, ellipse, that is vertex. Okay, to locate that vertex it's very important to divide this given particular length into 5 equal parts. That number 5 equal parts or 7 equal parts, that depends on the eccentricity value given in the problem. If it is 2 by 3, you need to add up 2 plus 3, 5 equal parts. Okay. Suppose I can even get less than 1 if I take 3 by 4 also less than 1. Okay. At that time, 3 plus 4, 7 equal parts I need to do this particular length. Okay. Later I will come to that question where what you are asking. Okay. Why 5 parts? Okay. You will understand uh, after some time. Okay. Then remember how to divide this line into 5 equal parts. Line division method you are familiar with, right? Line division method.
No,
Yes,
sir.
sir. Can
Line
you
division,
tell?
yeah, line division method means you will draw one inclined line here, taking 5 equal arcs. Okay, you need to join that arc, last arc to the focus, and drawing parallel lines with mini drafter. Have I explained earlier?
No, sir.
Sir, can you repeat once again, sir?
Yeah. For that, I am drawing one more thing here, since I did not explain earlier. Okay. For example, this is axis. This is directrix. Okay. This is axis, for example, and this is the focus, and this is the starting point of origin point. Okay, CF distance is total 50 is given in the problem, right? Now, to divide this line 50 mm into 5 equal parts, first you need to draw one inclined line like this, of any length, any angle, of any length, any angle theta. Okay. On that line, what you have to do is, for example, we need to divide this line CF into how many parts? 5 parts. 2 plus 3, 5 parts, right? So you need to draw 5 equal arcs on this particular inclined line. Okay, 5 equal arcs. You draw one arc here, second arc here, third arc, fourth arc, and fifth arc.
Sir, those should be distant, sir.
These arcs are equal. You can set any radius, but with the same radius, you have to draw 5 equal arcs starting from C. So starting from here, first you draw one arc here, and again same radius. Don't change that radius, but you can choose any radius, either 1 centimeter or 1.5 centimeter, like that.
I didn't understand, sir.
According to the space available in the drawing sheet, take 1 centimeter. Okay, you take more value. Okay, it occupies more space in the drawing sheet. Okay.
So from C only we have to draw all the arcs, sir.
No. From C, first arc will come. After first arc is drawn, from again from here,
Okay, sir.
again you need to draw one more arc, because all arcs must be same equal length. Okay,
Yes, sir.
understood?
Yes, sir.
Then fifth arc, last arc, you need to join to the focus. Okay, because we need to divide this CF into 5 equal parts. After drawing this line with ordinary scale to the focus, what you have to do is set your mini drafter scale. Your mini drafter is like this, right? L shape, right? Your mini drafter will be like looking like this. What you have to do is, you match one scale to this particular line. Okay, fifth arc to the line you have joined to the fifth arc to focus, right? You have to match drafter scale to this line, and tight the mini drafter knob. Mini drafter knob, you have to tight it. Okay, after that, move the mini drafter parallel to this line. Move the mini drafter parallel to this line from fourth arc and third arc and second arc and first arc. By doing so, what you will find is the length, CF length is there, right? Initially 50 mm is there. That length automatically divided 5 equal parts, like this. You can check with your divider or compass or with scale. You can see that all these all these parts are equal in length. Second part, third part, fourth part, and fifth part. Okay, this is the way you need to divide.
Sir.
Give, dividing the any line into equal segments, equal parts, n number of equal parts. Any question here?
Sir, once can you repeat?
Sir, please could you repeat it once
Please.
again?
Yeah, would like to explain once again. No, initially you are having 50 mm, right? CF. Okay. My task is to divide the CF length into 5 parts. 1, 2, 3, 4. How many parts are there? 1, 2, 3, 4, 5. These 5 parts should be equal. Exactly equal. Okay. I don't know initially, so I don't want to use calculator, right? So don't divide 50 by 5 equal to 10. Simply don't mark on this particular line. Okay. There is a procedure you need to follow, because all the time it is not 50. Sometimes if it is 53, 53 by 5, it is actually it is a fraction, right? At the time you find a difficulty. At the time you will find difficulty. So you follow one standard procedure. For that, what I am telling is, first, importantly, you draw one inclined line from C. What I said, what is the angle of this line?
Any angle.
Any angle.
Any angle. How many
Any
arcs?
angle.
How many arcs to draw on this line?
Sir, your voice is breaking, sir. Can't. Your video is also stuck, sir.
Yeah. So I can't do with the internet issue, but am I audible to you?
Yes, sir.
Yes,
Yes,
sir.
sir.
Okay. Now tell me how many arcs I need to draw on the particular line, inclined line?
5. 5,
Five.
sir.
5. Because the ratio is 2 by 3, you have to add 2 plus 3. Okay, 5 plus 2 plus 3. 5 parts. So how to draw the arcs? You can set any radius with your compass. Starting from C as center, you draw one arc. And from here, you draw one arc, one more arc. Like that, you have to draw how many arcs? 5 arcs. Then the last arc, what you have to do? Join to the other end of the line. CF is our important line, right? We need to divide that CF into equal parts. So last arc you need to join to the focus. Okay. Thereafter, what I said, use your mini drafter. Use your mini drafter scale. It is in the L shape, right? 90 degrees angle.
Yes.
Okay. So what you have to take is match your mini drafter scale, any one scale. Okay. Parallel to this particular line. This line you can join with ordinary scale. Okay. So what you have to do is you have to match your mini drafter scale, match parallel to this line. Okay. Match this line. Okay. And
The longer one, sir.
yeah,
The longer scale.
yeah, generally the longer scale you can match. Okay. And type the mini drafter.
And the shorter one shouldn't move, right, sir? It should be in that position only.
The
The shorter.
shorter you need not worry. Okay. Neglect that whatever it is going on. Okay. Just
Yes, sir.
match the longer scale, tight the mini drafter knob. Okay. And hold the mini drafter knob gently. Okay. Just move the mini drafter from here to here. You need to draw one more parallel line to this original line. Okay. So that is the advantage of mini drafter. Just move the drafter from arc to arc. Okay. You draw one more parallel line to the original line here. Okay. And you need to draw parallel lines like this. Okay. Just you need to match one of the mini drafter scales to this particular. Okay. Fifth arc to focus. We have joined one line with ordinary scale. Match to that. Okay. That line and tight the mini drafter. Gently move the drafter from arc to arc. Okay. Automatically you can create parallel lines. All these are parallel lines to each other. Okay. All are parallel. Also parallel to the first line we have created. Okay. In this way, you are dividing the given CF length into 5 equal parts. You can measure with your ordinary scale. All these 5 parts are equal. So without help of calculator, you can do like this. Even though it is 53 mm, not only 50, even if it is 53 or some unknown value, you can divide equal number of okay divisions. Okay. Now this is the way we need to divide. Now can I go back to our construction? Is
Yes,
it
sir.
clear?
Yes, sir.
Yes, sir.
Yeah. So now come to the next step. After getting this focus, divide this CF into equal number of parts. That is 5 number of parts. Now, after that, you need to locate vertex. Okay, vertex from moving two parts from focus. Moving two parts from focus. Okay, so the remaining three parts are there, left hand side of vertex. Two parts are there, right hand side of vertex. So this ratio VF by VC is known as eccentricity. That's why we are dividing this into 5 equal parts because the eccentricity is given 2 by 3. Okay. So if you take the formula VF by VC, you will get again 2 by 3 only because we are leaving 2 parts from focus and 3 parts from directrix. So still we will discuss what is eccentricity and its properties further. Okay. Now how to locate this vertex? How to locate this vertex?
2 parts from focus and 3 parts from directrix.
Very good. We need to move 2 parts. Remember numerator parts. Numerator you remember 2 is there. So leave 2 parts or move 2 parts from focus. That is the vertex. That is the vertex. And the next step is draw one perpendicular from vertex VE which is equal to VF. Very important, remember, because I will tell you, okay, why it is important, because the rest of the problems like parabola and hyperbola also follow the same procedure. You learn this particular procedure very much, okay? Don't neglect anything, okay? VF is equal to VE. Yeah, understood? The distance of VE is equal
We have to measure VF, sir, with scale and then draw VE. Or using drafter only we have to do that, sir.
See, yeah, better you always use mini drafter because uh, already you are having axis line, horizontal line. Match your mini drafter scale to the axis. Okay. Automatically, the other scale is automatically, it gives you 90 degrees only, right? So you need not use any protractor. If you use ordinary scale, it's very difficult to draw perpendicular line, right? So use always mini drafter. So that's why it's very important. Usage of mini drafter is very important. It's a multi-purpose. Earlier, while dividing the line into n number of equal parts, we have drawn parallel lines with mini drafter, right? For drawing vertical lines also, use mini drafter. So here, V is equal to VF. So you draw one perpendicular line that must be equal to VF. Just you can measure VF distance, okay, with compass. Draw one vertical line, just you cut with the same VF length, automatically you can locate this point E. Okay. After drawing this V line, what you have to do is join CE and extend that line. Join CE and extend that line further with mini drafter or ordinary scale. No issue. Okay. Thereafter,
Sir, what is the length of VE, sir?
yeah, that's why you are not listening carefully. VF, which is equal to VE. I'm saying repeatedly. VF is equal to VE. What is the length of VE? VF? What is the length of VF? You can measure with the compass.
2.
You can measure with the compass. Same length you can keep above. Okay. You draw one vertical line, cut that line with an arc. You measure that distance VF, and VE also must be same as that of VF. These two are equal, always remember. And extend CE further, you will get some inclined line. Okay. After that, next step, important step is you can take n number of points after vertex, select anywhere on the axis. Okay. You draw perpendiculars like this. So after vertex, I have taken first line, second line, third line, fourth line, fifth line. At so many lines I have drawn. These all lines are perpendicular to the axis. Okay, and starting with after vertex, I have to start, not before vertex. After vertex, I can select n number of points 1, 2, 3, 4, 5, 6, 7, 8, 9, like that. You can choose n number of points. And one more thing is,
Sir,
Sir, is the points equidistant?
yeah, that's why I'm telling. These may not be equidistant. If you are prefer to use equidistant lines, also nothing wrong. Equidistant. Okay. So you can select n number of points, no issue. Okay. But after vertex point, you can choose those points. After that, immediately name it as 1, 2, 3, 4, 5, 6, 7, and all. And importantly, these vertical lines from various points I have selected 1, 2, 3, 4. And if you extend above and below the axis, above the axis, we have extended one line, right? The extension line is there. Arc line, is perpendicular, right? So I call them 1 dash, 2, make the extension line as 2 dash, 3 with 3 dash.
sir, your voice is
Sir, your
breaking. We
voice is
can't hear, sir.
breaking. I can't understand anything.
Please wait. Issue. Okay. What shall I do? So it's LAN connected. Yeah, try to understand. Still breaking or can I?
No, sir, it's clear now.
No, sir.
Okay.
Now it's clear, sir.
Yeah, yeah. So it's internet fluctuations only. Okay, now whenever it is, so these perpendiculars we have drawn from various points 1, 2, 3, and so on, right? So these perpendiculars we meet the CE extension line. CE we have extended already. All these vertical lines, perpendicular lines are meeting at 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, 6 dash. Okay. So we have done maximum 90% of the problem is over. To draw the ellipse, okay, the last important step is take your compass, okay, set the radius, set the radius 1, 1 dash. This is the first radius you need to set with your compass, okay, and the center of the compass or the center of the arcs always is the focus, always focus. I have shown you here a red mark here, that is the focus point. The center of your compass is always focus, whereas the radius is changing continuously. The first radius of your compass is 1, 1 dash. 1 is on the axis, right? 1 dash is on the inclined line, C extension line, right? So take that radius first, that is the first radius I have mentioned here. This is the first radius, second radius, third radius. Any problem? Please mute yourself. Some disturbance is
So
coming.
we should take 1 dash and draw the arcs from focus, sir.
1, 1 dash is the radius.
And from
And
focus, we have to draw the arcs.
yes, from focus, you need to draw, you need to cut two arcs. One is above the axis here, I am showing you here, and below the axis also on the same 1, 1 dash line, you have to cut the arc. Okay. Similarly, what is the next radius you can take?
2, 2 dash.
2, 2 dash. And from where you need to cut the arcs?
Focus.
Focus.
Focus only always. Okay. And which line we need to cut these arcs? Again on the second line.
Then down.
Second line 2, 2 dash above and below. Above and below. Okay. Always focus is the center. So if you keep on doing like this, you will cut these perpendiculars at different points. Those are known as different points required to draw the ellipse. So you are able to see so many arcs, right? Okay. Repeat the same procedure 3 dash 4 dash so on. Okay. From focus you cut the corresponding vertical lines. Automatically you will complete the ellipse. After getting all these important points, you use your free hand. Don't use any French curves, okay, any mechanical tools. Use your free hand. Take HB pencil, join all the cutting points, okay, wherever the arc cuts these vertical lines, note down those points and join all the points with help of free hand only, with your free hand, okay. Then you would get a neat curve, okay, like this. This is known as elliptical curve. This is known as elliptical curve. Any doubt till now?
Sir, you told we have to yes, we have to draw an inclined line from C, like below, and we have to take any like radius of arc choice and cut, draw 5 arcs, right?
Yeah, that I have not shown here, but you supposed to draw everything. Okay.
You told us to do it with this drafter, no, sir? Like mark it parallel to that line.
Yeah, drafter only, but
Explain that step.
yeah, that I have not shown you, but you need to draw that line division method also. You need to show with 2H pencil. Don't erase. Okay. Don't erase. That is also need to be shown on the drawing sheet. Okay. Anything else?
Sir, for all the arcs, the center is focus, sir.
Yes, exactly. The but radius is changing. Okay. First radius is 1 dash. Next radius is 2 dash. Okay. That's why
So
you
what
see.
should be the measurement in the compass while taking the arcs?
Yeah, you are asking the same question again and again. First radius is 1 dash.
Okay. Okay, sir.
Second
Understood.
radius is 2 dash. Radius is increasing, right?
Okay, sir.
Yeah.
Understood. Thank you, sir.
But focus is here. That's why the reason why it is arcs are coming down. Okay. Initially the arcs are increasing. Okay. Thereafter the arcs are coming down because of the radius is increasing. The arc radius is increasing, but the focus is left hand side, right? That's
Yes,
why
sir.
right hand side the arc is coming down. Finally it closes. Okay. Till
Okay, sir. Thank you, sir.
yeah, till it closes, you need to take a number of points. There is no rule that you need to take 10 points, 11 points, not like that. Okay. Till the curve closes, you need to take a number of points. Okay. And that by practice you will come to know. Then thereafter important thing is we need to know how to draw normal and tangent. Okay. Suppose if you take any point here on the curve, already we have drawn elliptical curve. You take any point on the curve here, I am showing you. Join that point to focus like this. I have joined the focus and I got one line here, right? Perpendicular to that line, I need to draw, okay, one more line onto the directrix at an angle 90 degrees. Now, this is the first line. After selecting a point on the curve, I have joined to the focus. To that line, I have drawn perpendicular line which is intersecting the directrix at a particular point. So from that point, I have joined to the already selected point on the curve. That is going to be your
Any point of curve, sir.
tangent. Yeah, any question?
We
So
can
we
join.
need to draw that using mini drafters with that 90 degrees lines.
Always better because mini drafter scale is in the form of 90 degrees. Once you have joined this point to focus, you will get one line. Match that line to any one of the mini drafter scales. Automatically, the other scale shows you 90 degrees. Simply draw the 90 degrees line. Otherwise, it's very difficult using set squares or protractors. Okay,
Yes, sir.
always as far as possible. Okay, if you use mini drafter, you can save time. Okay,
Yes, sir.
and after getting this tangent, you can easily draw the perpendicular to the tangent. Again, using mini drafter. Just match the mini drafter scale. Just lose the mini drafter knob initially. Okay, without loosening that knob, if you simply rotate the scales, the mini drafter will spoil. Okay, so don't do like that. Initially it is in the tight condition, right? After that, to match this particular tangent, again you lose the mini drafter knob and match one of the mini drafter scales to this tangent. Gently tighten the knob and use the other scale in the mini drafter. You are having two scales. You draw one more perpendicular to this particular point. So normal and tangent are mutually perpendicular to each other. Now if you see the if you see with protractor, this tangent and normal, these two lines are 90 degrees to each other. Otherwise, you have done mistake. Okay. I think you understood, right, how to draw normal and tangent at any point on the curve. If you take that point here also somewhere, again join that point to focus, draw one perpendicular onto the directrix, join that point to the given point, draw normal and tangent at that particular point. Yeah. Any question? Can
So we can join the focus to any point, right, sir?
once again.
For the first one, we can join the point. We can choose any point and join it to focus, right, sir?
Yes, you can choose any point on the curve and directly join that point to the focus. That is the first step. Okay.
Yes.
You will get one line. Perpendicular to that line, you need to draw one more line. That will meet that directrix at a point T. Okay. Let us take it is a point T. Join the T to given point. Okay. That is the tangent. That is the same
Sir,
procedure. Yeah.
if the point is on the either side also,
Where?
if it is on the other side of,
Yeah, other side of the axis also the same procedure. If this point, if you
oh,
take
not that one, sir. I mean, if it is towards C dash,
towards C dash,
Directrix,
I
no, sir.
mean, point is on that side.
yeah, somewhere here you are saying, right? Towards C dash.
Hmm. Huh.
Yeah,
On 11th line, if there is a point, how will we find tangent?
yeah. If we this here it's to C dash somewhere here, you simply join that point to focus only. Okay, focus only. Okay, and draw perpendicular. Draw perpendicular to that line. Okay, that will meet the directrix. Or else, give me 1 minute time. I will tell you how to draw the second directrix, second focus, how to locate. Okay, second vertex, how to locate. Okay, initially you are having a single focus right here, so it is two parts away from the uh, vertex. So you measure the distance of VF with compass, and from, see here the curve is closing right on this axis, right? From here you can locate another focus somewhere here, because due to symmetry we can easily locate the second focus here. And this is the first vertex, and where it is closing the curve second side, other side, it is V dash, second vertex. And here you see the directrix is at a distance of CV distance, and from C dash V dash also same distance you can choose and draw one more directrix. Now as we are drawing normal and tangent, okay, from a given point we are drawing perpendicular to the directrix. Similarly, if the point is close to the next directrix, as she is asking, you can use this directrix as the reference and you can complete the normal and tangent.
Sir, can you explain once again, sir, please?
Yeah. So normal and tangent, here suppose there is a point here. I think is my screen visible to you?
Yes, sir.
I will. So here is a small point I am showing on the curve. Okay, this is selected point. Anywhere you can select on the entire ellipse. Okay, I have taken point here. That point you need to join to the focus. Okay, like this, and you got one line. Draw one perpendicular to that line. Okay, this is the perpendicular I have drawn. So that is meeting the directrix at this point. Join that point to the already selected point on the curve. That is going to be your tangent. Okay, take your mini drafter or protractor, you can draw perpendicular to the tangent, you will get one normal. Okay, so anywhere on the curve, anywhere on the elliptical curve, you can select anywhere one point. At that point you can draw normal and tangent. Okay, normal and tangent you can draw anywhere on the ellipse with the same procedure, right?
So what if we take the point from the line passing through focus?
Yeah, see here random points I have selected such a way that already we have done 5 equal parts, right? After vertex already I have got 2 points. One is matching with the focus, other one is in between vertex and focus. Okay, so you need not take points exactly matching to this focus and already existing points. You can choose a number of points at anywhere equal or unequal distances, so no issue.
So that point we should take after focus.
Yeah, you can also take 1 point after focus, 1 point before focus, but you need to start the taking these 1 2 3 4 point 7 8 points, all these points after vertex. That is the condition, because the curve is starting at V vertex. We need to join these points with V as the starting point and end with V. Okay, start the curve like this and end with the vertex. Vertex is a special point on the ellipse, but also it is point on the axis also. That is the specialty of vertex. Okay, now we will discuss in detail what is eccentricity, why we are taking this ratio 2 parts and 3 parts left side, 2 parts right hand side. There are two important properties of an ellipse. Let us see one by one.
Sir,
Yeah, please tell me.
which pencils do we need to use to draw
Yeah,
tangent?
yes. Normal and tangent you can directly use HB pencil. Okay,
Yes,
dark
sir.
pencil. Okay, remaining procedure, this line and perpendicular line, all other lines you can use 2H pencil only. Okay, except this curve, elliptical curve. Elliptical curve you can use HB pencil, dark. Okay, except that
Okay.
ellipse and except this normal and tangent, all other lines, even axis, directrix, all line division method, all these perpendiculars, okay, extension lines, everything with 2H pencil. And while writing 1 2 3 4s and letters, you can use HB pencil, dark pencil. This is the standard rule entire semester. Okay,
Okay, sir.
wherever we we feel.
Sir, what do those dotted lines indicate, sir?
Yeah, here I am explaining property 1 with help of these dotted lines. Here there is no importance. I can use continuous lines also instead of dotted lines to show you the difference between. If I draw again continuous lines, you will be confused. Okay, to explain one property, I have shown you dotted lines. Nothing wrong. Okay, nothing else. Okay. Now here property 1 says, uh, actually the by definition I told you VF by VC is the eccentricity of an ellipse. Okay, that means if you take any point on the ellipse, it moves in such a way that this ratio is always constant, Vf by Vc. That means if I take one point, that is vertex, which is also on the ellipse, right? It is also on the ellipse as well as on the axis. What I mean to say is, if this is the point vertex, this point moves from here around the total path of the ellipse. Okay. So initially, for example, on the axis it is here. So the ratio Vf, the point, the distance of this vertex from the focus, okay, if that is Vf, and the same point, okay, that is vertex to the directrix, that is C point, the distance Vc, means that ratio Vf by Vc is always constant. Okay, even if it moves from the axis point here V2, some it goes to P1 or P2 or P3, somewhere it is going on. Okay, it is moving, but the ratio is constant. That I would like to explain. Okay, for example, this vertex is moving from here to, let us take one point P1 on the curve somewhere here. Are you able to see the P1 here? Somewhere I have shown you P1,
Yes, sir.
and somewhere it is P2. Okay,
We can take those points anywhere, sir.
anywhere. For understanding, I have taken P1 here. Now join that P1 to focus with dotted lines. Okay, and the same point you join to the directrix at C1. Earlier it is Vf by Vc, right? Now V is changing its position from V to P1. Now what is the ratio? Can you tell me?
C1 P1
P1F by
P1.
P1C.
C1.
P1C1.
Yeah, same thing I have written. P1F by P1C1. Again, you can compare previous ratio Vc by Vf by Vc 2 by 3 only, right? Because total distance is 50, Vf is 20, Vc is 30. Okay, the ratio 2 by 3 we have done. Then when it is moving from vertex to this point, again it is moving to P1. What is happening here? P1F is increasing. Again, P1C1 is also increasing. That means the ratio becomes same. It's constant only. Okay, understood. Earlier it is Vf, now it is P1F. Okay, after some time this P1 goes to P2, again it is P2F. P2F is greater than again P1F. P1 is greater than Vf. Even though numerator is increasing, okay, the horizontal distance of that point to the directrix, like Vc, is also increasing. That means what is happening here? The ratio is constant. Otherwise, it cannot be called as an ellipse. Okay. Is there any question
Sir,
here?
I'm confused. Explain again, sir.
Yeah, this vertex point initially here on the axis, right? It is, for example, it is moving along the path of ellipse to P1, for example. Okay, P1.
So from F, it can be any point and any length, sir. P1, P1F.
Yes, that's why what I'm saying. Yeah. So initially, when vertex is on the axis, only Vf is the distance, right? Vf
Yes,
is
sir.
the distance. But when the vertex point is moving along the curve, let us take this vertex is going to P1. Okay, I am giving some other name for vertex now. Okay, I am giving
Yes, sir.
some other name to the vertex as P1. Now, what happening? You see the ratio, see the distance. P1F is increasing, right? Earlier it is only Vf,
Yes, sir.
only Vf, but now it is P1F. That means numerator is continuously increasing, but denominator. What about denominator? Earlier, what is the denominator initially? Vc only, right?
Please.
Vc initially. Now I have given other name to vertex as P1. Now vertex is here at P1. Now this is the horizontal distance, right? In earlier it is VC, 30 distance, right?
Yes,
Now,
sir.
par-
It is P1C.
now parallel to that VC, the distance is P1C1. Now
Yes, sir.
compare these two. P1 C1 is also increasing, right?
Yes, sir.
That means according to the definition, PF by PC or VF by VC, okay, VF by VC is fixed one, right? It is something like on the axis, VF by VC is constant.
Yes, sir.
Okay, that is the initial given eccentricity value.
Yes, sir.
The property of ellipse is, even though if you travel along the path of the ellipse, okay, the ratio, okay, the VF by VC ratio or P1F by P1 C1 ratio is constant.
Yes, sir.
If you take P1F by P1 C1, since P1F is increasing, P1 C1 is also increasing, okay, the
Yes, sir.
final the final answer is only 0.667. Okay,
Sir.
that is the property of ellipse.
Sir,
That is
even
property. Yeah.
can we change V dash and C dash also, sir, instead of V and C?
Yeah, same. Actually, see, the right-hand side, I have drawn one more directrix, one more
Yes.
vertex. Nothing, no difference. Okay, by symmetry, you
Yes.
can think that both are same. There is no difference. Okay, and coming to the next important property, do you know uh, the major axis and minor axis concept?
Somewhat, sir. Like 2A, 2B will have something, right?
Okay, it's very simple. The distance between vertex V to V dash. This is the major axis. Okay, the distance from V to V dash. Okay, this is major axis, and if you bisect this major axis exactly at the midpoint, if you draw one perpendicular, that is the minor axis, right? Now, why I'm telling is, if you take any point, let us take P3 point somewhere here. Okay, to the focus 1 and the same point if you join to the focus 2. Where is the focus 2? I told you at 20 distance only, right? From other vertex it is only 20 distance. Okay, by symmetry you can take other focus here from V dash, again it is 20 mm distant. Okay, now the property says if you join P3 to F and P3 to F dash, okay, the sum of P3F and P3F dash is equal to any answer?
VV
That's,
dash.
V
yeah,
dash and C dash.
exactly. VV dash. That is the major axis. That is the major axis. Okay. So I think these two are sufficient for understanding the concept. Here I am showing you P3F property 2 plus P3F dash is equal to VV dash length of major axis. Okay. I think these properties are sufficient in general to learn something like conic sections. Okay. So I hope you can able to make up the drawing, right? Can you draw on your drawing sheets? Maybe can you come with a complete solution? Uh, can you do this? Any questions?
We
So
would
drawing
require
the
your help,
parallel
sir,
lines,
while doing it.
One by one, one by one.
so drawing the parallel lines using the drafter. Once again, you'll explain, sir.
Yeah. Uh,
One and
you are asking line division method, right?
Should we match both the scales, sir, to
No,
that
no,
line?
no, no. Only one scale. Okay. Once again, I will show you here. See, after drawing five equal arcs, right? Five equal arcs, how to draw?
Yes, sir.
what you have to do is the fifth arc you need to join to the focus. You will get one line here, right? You will get one line here. Okay. You need to match this line with one of your mini drafter scales. Okay, there is a 90-degree scale. Your mini drafter is having 90-degree scale, right? So it will be something like this. You can match longer edge of that scale. You can match here. Tight the mini drafter. Just move the drafter. Automatically, you will get the parallel lines like this. Okay, you need not worry about the other short edge of the mini drafter. Okay, longer edge you can just match to this particular line. Just move the drafter after tightening the mini drafter knob. Okay, just move the drafter parallel to this particular line. Am I clear?
Yes, sir.
Any other questions from this ellipse?
No, sir.
Yeah. So you need not write anything on the drawing sheet, calculations, theory, anything, nothing. You need to write anything on the paper. Only you need to draw ellipse, normal and tangent. Okay. So you use the pencils as I instructed. Okay. Now, what is the time now?
240.
Yeah, it's almost. So time is up, right? Time is over.
Yes, sir. So next class you will be making us draw this, sir.
Next time you come